So I believe next up is Noah Petro, talking about LRO and future prospects for data acquisition to support landed missions. Noah, are you here? Oh, there
I
you are.
I hope I'm here.
Hi. All right, go
Hey,
for it. I guess when your slides come up.
okay. So thanks for the opportunity to talk about LRO, my favorite subject. Let's begin. So first of all, everyone should be aware that tomorrow morning, early tomorrow morning, we have a very exciting event occurring. There will be a partial uh, lunar eclipse. As a reminder, during these sorts of events, let's go to the next slide, please. Um, LRO powers off the instruments, we heat the spacecraft up, goes through this wonderful natural event. We've been through many of these eclipses before. Now that we're almost coming up on next year, will be 13 years in lunar orbit. These eclipses present very challenging opportunities for us to fly through, but we've done it multiple times. So we have every confidence that starting tomorrow afternoon, we'll power on the spacecraft and everything will be ship shape and ready for many more years of operations at the moon. Of course, these eclipses become major events for the spacecraft. For folks that remember Laddie, Laddie was faced with going through an eclipse. They weren't sure if Laddie was going to get through it. Of course, Laddie did, but eclipses present challenging environments. This week is no exception. Let's go to the next slide, please. Tuesday morning, LRO didn't phone home. We thought there was a processor problem on the ground with the antennas. It turned out that LRO had experienced a processor reset. And why do I mention this? Over the several hours of Tuesday into Wednesday, and indeed the course of this week, the ground team on LRO did an incredible job. They figured out what was wrong, diagnosed the problem, turned the instruments back on yesterday to preheat the spacecraft for an eclipse tomorrow. This was perhaps one of the most challenging weeks in LRO's operational history, and I have no doubt that starting tomorrow, we'll be back on the road to normal operations. Now, I don't mention this for any cause of panic to the community. LRO is a robust spacecraft. Part of that robustness is our ground team. And as a reminder to folks at headquarters and everyone planning missions, you cannot skimp on operations staff and ground teams. You need to be paying the people who keep your spacecraft safe you can't have them be part-time. This is a full-time job keeping LRO operating. And so as a reminder, we're talking about low-cost missions. One thing you cannot have low cost is your ground team. We have been through this before with LRO. In 2010, we had a power on reset, which was a much more challenging event. So many folks on our team remember that. And we did this in 2019 to reset the system. So we had a playbook. We had the personnel who'd been through all this before. And so as a reminder, particularly, short-term missions, fine, but as you get into longer-term missions, you want some institutional memory of how to do things. LRO performed amazingly through this operation, through this event, and did everything we asked it to do, we expected it to do, and that's why I know that we'll be able to go forward. Next slide, please. Part of keeping a spacecraft healthy is, having a team that monitors everything that goes on the spacecraft. Our systems engineers monitor our battery, our fuel, our solar array, so that we don't only operate today, but we operate tomorrow and for the distant future, so that for all of the missions that we plan and want to have going to the moon, we have LRO as an asset there to scout out these landing sites and collect the data that we feel we need to make these missions possible. Let's go to the next slide, please. Okay, let's talk a bit about the future. I know that the slides are jumping around, but let me just state that basically we have used effectively 98% of our fuel. We're in this fuel efficient orbit, and going forward for the next several years, it looks like that LRO will be in a roughly 100-kilometer circular orbit. We have about 13.7 kilograms of fuel left. It looks like fuel is our one rate limiting factor for life. We need fuel to unload momentum. We need fuel to phase our orbit, put our orbit in the proper configuration so we minimize the time in darkness during eclipses. And of course, if we had to tweak our orbit to, say, observe a landing, if we had to do that, we would use fuel. That is the remaining resource. Our natural orbit drift to this 100-kilometer circular orbit means that we don't have to use fuel to trim or maintain orbit, that we can just essentially let Sir Isaac Newton drive us. Part of that driving also means that we are drifting away from the poles. Right now, our orbital inclination takes us about 85.5 degrees latitude. So we're about just under 5 degrees away from the South Pole, when we slowly are drifting away from the South Pole. Now, again, we've been at the moon for over a decade, and we have collected an amazing amount of data for the South Pole. So it's not like we're missing anything. But for the landed missions that want to target South Polar landing sites, we either have to rely on the data that we have collected or off-nadir observations of polar targets. As a reminder, we are in preparation for our next extended science mission proposal, which will take us from September of next year. It's hard to believe that next year is already 2022, through September of 2025. And as a reminder, we have about 5.5 years of fuel left in the tank, which would take us through April of 2027. Next slide, please. So, one of the great outcomes from today will be a set of potential targets for LRO. And so we'll harvest the locations that are discussed as inputs into our targeting scheme for ESM 4, which we're in right now, and into ESM 5. On the right, I list, this is from our last extended mission proposal, but it's basically the menu of options that we have from each of our instruments. Types of observations, observational strategies that we can have. And so for any targeted observation, such as a landing site, we can potentially unfurl a number of different observations of potential landing sites. It should be noted, of course, some things have changed on the spacecraft. So for instance, for mini-RF, we no longer can use the Arecibo observatory to illuminate the moon. But we have other ground-based assets that we can use with our mini-RF for Earth-facing radar observations. And again, nadir observations for LRO are limited to 85 degrees and equatorial. And I would remind everybody that we have a special new position on the project science side. Maria Banks, who's part of this meeting here today, is our project science liaison for future missions. She's been working with some of the upcoming CLPS providers to help them find the existing data, put in requests for future data, collections from our instruments. And so, teams should feel free to contact Maria with special requests, but certainly once a mission occurs, becomes a fully fledged mission, we begin in earnest the discussions with those teams to begin targeting and collection of data. As a reminder, though, the sooner the better. The moon is a wonderful place to operate, but we only have limited opportunities, for instance, to collect stereo observations of a particular target on the surface. We only have certain opportunities to image a site at early morning or late afternoon lighting conditions, or collect photometric observations. And so the sooner we can get these observations into our plan, the better. Again, I look at that 5.5 years of fuel left on LRO and say,
2 minutes.
We're on the clock. I've got 2 minutes, so I'm on the clock as well. So the sooner the better that we can begin planning and implementing these observations for your targets. Next slide. So, one of the things I want to mitigate expectations of is that we'll be able to observe every landing. Observing a landing or a landing attempt, hopefully no more litho-braking events, is challenging. We have to put the spacecraft in a very specific position, which means using fuel. Again, fuel is our one limited resource. And so unless we have months of planning, knowing that a specific mission will launch several months later, landing on the moon, it's really not going to be feasible for us to be at the right place unless we're fortunate. So for instance, on the right, Chang'e 5. Chang'e 5 landed. LROC was able to acquire an image after landing, but prior to the sample return canister launching from the surface. And of course, several months later, we were able to observe the landing site after that launch occurred. That was fortunate. We were lucky. We cannot count on that for every future landed mission, but what we can count on is, again, proper planning. We are excited to support future landed missions, not just for identifying sites, but if we are able to make coincident observations during the spacecraft operations period of time, I think there's an opportunity for synergy between those observations. The LRO team can generate specific products for teams and then shared with the universe through the PDS. but this needs to be discussed ahead of time and planned. And I would remind folks that one of the great new products that's coming down the line are these improved 5 meter per pixel DEMs that are coming from the Lola team. Mike Barker and Aaron Mazrico are generating these products, and they're available at the website at the right. With 5 seconds to spare, I'll conclude and thank you for your attention today.
Thanks, Noah.